Good morning, students. Students, this lesson is of class 10th for the subject of physics. Topic: numericals based on kinetic and potential energy, which is covered in chapter 2, work, energy and power. Exercise 2B of your textbook titled Concise Physics by Selena Publications, and this lesson is submitted to you on 12th July 2021. Now students, before starting the numericals, let us recall all the formula which we did last week. So children, we have studied the formula of potential energy, which is given as product of mass, acceleration due to gravity, and height of the object above the ground. That is, potential energy can be given as mgh. Similarly, kinetic energy is given by formula half mv square. That is half multiplied by m multiplied by square of velocity of the object. And there is one more formula for kinetic energy, which is equal to p square upon 2m, where this p refers to linear momentum and is given as product of mass and velocity. Now, children, you all open page number 41 of your textbook and also open your notebook to practice the numericals side by side. So now let us learn to do the numericals here. Children, first of all, read the question. Question number 1 given in your book. So what is question number 1? Look in your book, please. So question number 1 is two bodies of equal masses, so though two masses are same, the objects, the two bodies are having same masses and they are placed at height h and 2h. What does it mean? Suppose one body is A and it is at a height of h from the ground, and the other is a body B which is placed at height 2h from the ground. Both are having same masses, but the heights are given to be different. So A is at a height of h, while B is at a height of 2h. So let's find the potential energy of A. So potential energy of the first part can be written as, or you can say potential energy of object A is mgh, while potential energy of B, the object placed at height 2h. Now, this object is having same mass. What does it mean? It means that if A is having m mass, the mass of B is also m. So potential energy of the B particle can be written as m. G will be same for both the things, but the height now will become 2h, since the height from the ground is 2h. Now they are saying find the ratio of gravitation potential energy. So potential energy of A divided by potential energy of B. Divide both the terms, children, and see what your answer is coming. mgh divided by mg2h. Cancel out the things which can be cancelled. M will be cancelling with the m in the denominator. Similarly, G will get cancelled and H will also get cancelled. So I'm left with, in the numerator it is only 1, while in the denominator the answer is 2. So what is the ratio coming? Our ratio will be 1:2. So this is our answer. Understood, everyone? So now let's go to the other question, question number 2. Now children, see question number 2 in the book first. Read the question and see what is given. In question number 2, they are saying that find the gravitation potential energy of mass 1 kilogram. So the mass is given to be 1 kilogram and is kept at a height 5 meters above the ground. So the height above the ground is 5 meters. Calculate its kinetic energy when it falls and hits the ground. Now children, we have done in class 7th conservation of energy, conservation of mechanical energy. We'll do that part here also in the next exercise. The topic is conservation of mechanical energy. So what happens in it, students? That energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. It converts from one form to another. So here also, if there is an object placed at point A and it is at a height of 5 meters from the ground, so there will be certain energy possessed by it. The energy possessed by a body kept at a height is known as potential energy. And when this object starts falling down, its potential energy decreases. Why? Because the height from the ground decreases. But as soon as this object touches the ground, whole of the potential energy becomes zero and it gets converted into kinetic energy. So what I want to say here, that when the object was at a height, whatever its potential energy was, whatever the value of potential energy at a height, when the object strikes the ground, whole of the potential energy becomes zero and it gets converted into kinetic energy. So what is happening here? When the object is coming down, when it is falling down, its potential energy starts decreasing and kinetic energy starts increasing. Actually, students, here at the top, you will be having maximum potential energy. Potential energy will be maximum, while your kinetic energy at highest point is 0. And as the object starts coming down, its potential energy starts decreasing and the value of kinetic energy starts increasing above 0. And what happens when it reaches at point, this body reaches at point at the ground? As soon as it strikes the ground, then what happens, children? Then potential energy becomes 0. Then what happens? Potential energy becomes 0 and kinetic energy becomes maximum. So kinetic energy will become now maximum while your potential energy will become 0. So now kinetic energy is maximum. That means whatever is the value here, suppose potential energy is 1000 joules at a height. When the object strikes the ground, potential energy will be 0, but kinetic energy will become 1000. This is known as conservation of mechanical energy. So in this second question, we will be using the concept of conservation of mechanical energy. So children, at first the question is asking that find the gravitational potential energy. So first of all, the question is, see, find the gravitational potential energy. So that we know the formula, that potential energy. Write down the formula yourself. I've already written. What is the formula? M mass into gravitation, acceleration due to gravitation into height of the body. And now place the values here. Do yourself, students. Hurry up, very good. Mass is 1 kg, G is given to be 10 in the question, and height is 5 meter. So multiply all the things, what you'll get? Your answer of gravitation potential energy will come, it will come 50 joules. See, isn't it? So the answer comes out to be 50 joules. So that is our answer, 50 joules. I hope you all got the answer. Okay, so very good. So now coming to the next part, that is calculate the kinetic energy when it hits the ground. In such question, you will write down according to conservation of mechanical energy. You have to write down this mechanical energy, comma, if there is no loss in energy. If there is no loss in energy, then what will happen? Whole of kinetic energy, you write down kinetic energy at the ground is equal to potential energy at the given height. So here, what will be the value of kinetic energy? Kinetic energy will be equal to 50 joules, because at the height you are having energy as, what was your potential energy? It was coming to be 50 joules. So children, this 50 joules, when it reaches the ground, when the body reaches the ground here, then whole of this 50 joules of energy gets converted into kinetic energy of the body. So I hope this is clear to all of you. Very good. So kindly note it down, and children, this line is very important to be written. If you're not writing down this line and you're directly writing down the answer, your marks get deducted, because you have to tell why you are taking kinetic energy as 50 joules. So this whole property which you are using, it has to be written in the same format. So coming to the next question, children, now. Question number 3. This question you can try yourself, since now you are very much familiar with numericals of exercise 2A, and I have made you revise everything. So see question number 3. Question number 3 states that, what is in question number 3? A body of weight 150 kilogram force, kgf stands for kilogram force, has gravitational potential energy. Potential energy is given to be 14700 joules. Find the height of the box above the ground. Now children, weight. First of all, you can convert weight into Newton, and I've told you how to do it. You'll write down 150 multiply by acceleration due to gravity, which in this case is given to be 9.8. So 150 multiply by, what you'll do? 150 multiply by 9.8 newtons. The answer now can be written as Newton. No need to solve it further. We'll do the calculation at the end only. So now let's put the formula of potential energy. The formula of potential energy is equal to M multiply by G multiply by H. Now children, pay attention. This M into G. M into G is known as weight. The formula of weight is, you are doing it since class 7th. Weight can be written as mass into acceleration due to gravity. M stands for mass, G stands for acceleration due to gravity. So product of mass and gravity becomes weight. So mg into h. So can I say that mg is weight, which I can write down like 150 multiplied by 9.8. Height I have to find, and potential energy is 14700. It's given to us. Now children, keep h on one side and the rest of the thing in the denominator. So 150 multiplied by 9.8. And now do the cancellation part. Your height will come 10 meter. Will you be able to do? See how to do this thing? First of all, you can cancel a 0 of 150 with 14770. Okay, 14700. And then cancel with C. This can be cancelled, and if you just start cancelling 1/4 or you divide it with 15, see 1470 divided by 15. Okay, so 15 nines are 135, nines are 135, and then what will happen here? 147 minus 135 is, what is it? Very good, 12. So this becomes 120, and 15 eights are 120. So basically, if you cancel these two things together, you'll get 98. And this is 9.8. Remove the decimal such that you can bring a 10 here, and then you can cancel this thing. So your height comes out to be 10 meter. That is your answer. Similarly, now question number 4. A body of mass 5 kg, mass is 5 kilogram. It falls from a height of 10 meter to 4 meters. So it is not reaching to ground, it is falling from, let it be initial height, and it is reaching till 4 meter. Now calculate the loss in potential energy. So how to find loss in potential energy? Children, write down the formula. You can say loss in potential energy is equal to initial potential energy minus final potential energy. This is loss. Initial potential energy minus final potential energy. That means mg into h1, height, minus mg into h2. Take mg common. You're left with h1 minus h2. Subtract 10 minus 4. M is given. G is 10. Substitute the values. And children, find the answer of loss in potential energy. Now you do this question yourself. Fine. There is one more part here in the question. So they are saying, what is the total energy? Total. So total energy will be same. What I told you earlier, that when it is at maximum height, potential energy is maximum and kinetic energy is 0. So if you take the sum, so total energy will be the same, which is the potential energy at the maximum height from the ground. So here in this case, what is the maximum energy, maximum height from the ground? Is it 10 meter or 4 meter? Yes, we will take 10 meter. So mass 5, G10, height is also 10. So your answer for total energy will come out to be 500 joules. Fine. Very good. Excellent, children. Yes, students. Now, after doing 4th question, just pause your session, and then you do question number 5th and 6th yourself in your notebook of physics. Kindly try these two questions. They are very easy questions. Question number 5th and 6th. So now let us do numerical number 7th. A vessel containing 50 kg of water. So mass is 50 kilogram. It is placed at a height of 15 meters above the ground. Children, just remember this thing, that you are not supposed to convert kilogram into gram. Do not convert kg into gram. Kilogram is the SI unit of mass. So keep it as it is. So mass is 50 kg. Height is 15 meter. Now assuming the gravitational potential energy at ground to be 0, what is the gravitational potential energy of water in the vessel? So they are saying, suppose at the ground potential energy is 0, you find the potential energy at this place. Now can you find it? This is also very easy. So this question is also for you people only. Just put the values of mgh and get your answer. So you do your question, 7th question also yourself. And students, even after doing 7th question, you can try question number 8th yourself. That is also very easy. So I am coming to question number 9th now. So you have to do question number 7th, 8th yourself, and 5th and 6th also yourself. So question number 9th. Now see, this is an example also. There is an example of such kind. Now here you are having an inclined plane. So this is an inclined plane. Okay, here you are having an inclined plane like this. And they are saying there is a box. There is a box placed at the corner of this inclined plane. Here it is a box here. Okay, so this is a box here. There is a box. This is a box. Suppose let this box be A. The name of the box is given to be A. This is a box placed over here. So this is A. The height of the inclined plane from the ground is 3 meters, while when you are moving this box upward, when you are applying some force here, this whole distance, this hypotenuse is given to be 5 meters in the question. So children, now the question is, a block A weighing 100 Newton. So the weight of object A is 100 Newton given in the question. It is given to be 100 Newton. It is pulled up a slope of length 5 meters by means of a force. Now you are applying a force, and luckily that force is also given to be 100 Newton. I am applying with the force of 100 Newton. So the first part of the question is, what is the work done by the force in moving the block upward? Work done. Just remember, we did in first exercise. Your force is upward, you are pulling it upward here in this direction, and see, the displacement is also along this direction only. The object is moving like this. So I've told you also, students, this formula is done in first exercise. You are right now also doing in your classes. Formula is Fs cos theta. And if the two things, force and displacement, are along same direction, then angle will be taken as 0 degree. Very good. So I'll write down force is 100 Newton, displacement is 5, and cos 0 degree. 0 degree is cos 0, 1. Excellent. So work done will be 500 multiplied by 1. It becomes 500 joule. So this is the work done by the force F. The force F which you are applying, the work done by the force F in moving the object upward through an inclined plane, which is having a slope of 5 meters. Okay, along the slope of 5 meters. So the next question is, what is the increase in potential energy? Children, when we did loss, I told you loss in potential energy was initial minus final potential energy. Loss means initial minus final potential energy. But when I am talking about increase in potential energy, that is something else. So I'm writing both the formulas here. Loss in potential energy is equal to, see, loss in potential energy is initial, because initial potential energy is maximum, minus final potential energy. While if I talk about increase in potential energy, the formula becomes so so let's write down increase in potential energy. So increase in potential energy will be equal to, if you write down increase, it will be final potential energy minus initial potential energy. Loss means decrease. Whenever you are talking decrease or loss, that means initial minus final. And if you want to write down increase, it will be final minus initial. So in this case, find the increase in potential energy. So what is the final potential energy? The object was here. It is reaching the ground. It is reaching above the ground at a height of 3 meters. So children, in this case, what you'll do when you are finding the answer here, children, in second part, your final potential energy will be mgh, where mg is the weight of the body, and the weight of the body is also 100 Newton given in the question. Block weighing 100 Newton. So mg is weight 100 multiplied by height. Height will not be 5 meters. Height is above the ground. So if this is the ground, this is the place where you are reaching. So it will be 3. So final potential energy is 300 joules. While initially you started from the ground, so 100, height will be 0 from the ground. So initial energy, potential energy is 0 joules. Substitute the value, you will get the answer as 300 minus 0, that is 300 joules. Fine? Do this question. Yes, students. So here in this question, our first answer, the work done by the force was 500 joule, while increase in potential energy is only 300 joule. So now the next question is saying that why there is a difference between the two. Actually, what is happening? You are doing a work of 500 joule by applying force, but only the increase in energy is 300 joule. That means there is certain loss in energy. How much is lost? So the difference between the two is coming to be 200 joules. This 200 joules of energy is lost. Why it is lost? Look here. The object A is in contact with the surface of slope. Whenever the two objects are in contact, we did in class 8, contact forces. When the objects are in contact with each other, there comes friction between the two objects. And because of that frictional force, there is certain loss on energy, and that loss in energy occurs as heat energy. Because of friction, heat energy will be in this system. So 500 joule work was done, 300 joule of increase in potential energy happened, and 200 joule is lost in form of heat energy. Why? Because there is a friction between the two surfaces since they are in contact with each other. So this is a very important question. Question number 9. Do it carefully and understand one more time. So similarly, students, question number 10 is find the kinetic energy of the body. The formula of kinetic energy is half mv square. Now use this formula. Velocity is given in this question. Question number 10, and even mass is given. So you find this kinetic energy yourself. This is your homework again. Coming to 11th question. Now, if the speed of car is halved, how does its kinetic energy changes? So in this thing, we'll do two parts. First of all, I'll write down initial kinetic energy. The formula will be half m square of u. U stands for, what is u? U is initial velocity. Isn't it? What is u? U is initial velocity. So final kinetic energy. Final kinetic energy is half mv square. V is final velocity. And they are saying that this velocity is half of the original velocity. They are saying velocity is halved. So instead of v, I am writing u by 2. I am halving this velocity. So if original velocity was u, final velocity is half of the original velocity. So find the answer. It will be half mu square by 4, final kinetic energy. Such a question is also there in examples. So students, see this half mu square. Can you see somewhere written on the screen? See, at the topmost point. So how I have referred half mu square? I have referred it with initial kinetic energy. So here in my question, I can write down that final kinetic energy is initial kinetic energy divided by 4th. That means that when you halved the velocity, kinetic energy became 1/4. So this is your question number 11. Such questions need to be done in this manner. Is it fine? Very good. So children, coming further, now after this, children, question number 11, I have told you, you will be doing 12th and 13th question yourself using the formula of kinetic energy. And similar is your 14th question also, that a car is running at a speed of 15 km/h. No need to convert kilometer per hour, but if it is required, if they are asking, this is the way you convert kilometer per hour into meter per second. So kilometer per hour can be written as 5/18 times meter per second. Though it is not required, I have just mentioned to make you remember the way we used to do it. So children, let's do further. In this question, kinetic energy half mv square. Initial velocity is 15 km/h, while there is one more car moving at a speed of 45 km/h, having same mass as the first. So now you have to take the ratio. So just divide these two equations, you'll get the ratio of kinetic energies. So 14th is also very easy question. Similarly, children, question number 15th and 16th you can do very easily. You'll do yourself. But in 16th question, one thing you have to remember, the mass in question number 16, see, a cannon ball of mass 500 gram. Now this is gram. What to do? Let's convert grams into kilograms. So how to convert it? 500 divided by 1000. It became kilogram. So it is 0.5 kg. And then we have to find kinetic energy using the formula and linear momentum using the same formula. So now students, whatever are the leftover questions in this video, you have to do those questions yourself in your notebook. And then afterwards, you can also try all the remaining numericals from numerical number 17 to 23. With this, I come to an end to this interactive session. I hope you all have understood. If there is any doubt, we can clear the doubt in your online classes also. So thank you, students. Have a nice day.